What's up, guys? Here we go. We're going to continue section 7 and roll in here to section 8. So this video really is going to be on section 8, and it says statements of logic right there in the middle of the screen. But we're going to continue talking about these conditional statements where we have something written in the form of if, then. If P, then Q. If an angle is between 0 and 90, then it's acute. If an angle is 180 degrees, then it's a straight angle. Something like that, to that effect, that we're going to roll into. Now, funny little joke here for you. Check this out. It says, penguins are black and white. Nice little penguin. And then he says, wait, some old TV shows are black and white. So his logic that he could conclude from his understanding was, therefore, some penguins are old TV shows. Ha! Penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. Well, as it says down here, the logic, another thing that penguins aren't very good at. Funny. Either way, doesn't matter, but it's a logic statement. We're going to talk a little bit more about what we can do with these conditional statements. So you already have this in class. We started this foldable flappy with deductive structure up here. Sorry, my screen only allows me to show this. You can barely see it. It says key vocabulary here in the bottom, which we did that in class. We're going to fill out this flap, this second one, third one, and fourth one on this video. So let's do it. So, the very first flap that you need to fill in right here, I actually moved this up, so I kind of cut off key vocabulary, which is underneath this flap right here. The very first thing that you need to put on here is this word negation, and what it means to take a particular statement, not a conditional statement, just a declarative statement, and negate it. And this, by the way, is your little symbol. So let me show you a couple examples of that. So what you see here on the screen is a simple statement that says, it's raining. Over here this says the angle is right angle. This one says the angle is acute. This one says this segment is not 4 centimeters. They're not conditional statements if you notice. They're just declarative statements. But here's how you take and negate these particular things. So if you would take this one, you would say it's raining. The negation of that is, whoops, sorry. It's not raining. It's that simple. This one over here, the angle is a right angle. The angle is not a right angle. That's what you're doing when you're negating these things. The angle is acute. The angle is not acute. The segment is not 4 centimeters. Then you would say the segment actually is 4 centimeters. So the negation is when you take something and just make it the negative of it. So if it's already negative or if it's already not, then you take it the positive, if you will. So, in general, though, here's the scoop. And you can write this on the front of your foldable. So if you have a declarative statement P, like we talked about in class, whatever it is, the negation of that is what we say not P. It looks like that. So this one would be if it's raining, it's not raining. If it's an acute angle, it's not an acute angle. If I'm not cool, then I am cool. That's the negation of a particular statement. All right? So now what I would do, again, if I was you, I don't know if you did this or not, but up here where it says negation, I would write this P right there, and then over here I'd write not P. So there's your example for that. Okay, so what comes next? Well, what comes next is this. You got negation. The next thing that you'd have is something called converse. So you can write that in your foldable flap right there. And here's the thing. The first thing that I want you to think about with converse is, well, what comes to mind? For me, converse is this. It's a shoe. Very true. But how I want you to think about converse is this. When you converse back and forth with someone, when you talk back and forth to someone. But I want you to think of this word converse not quite like a Converse shoe, more like a flip-flap. So you're going back and forth, flip-flap, 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 conversation back and forth, back and forth, back and forth. Because when you take the converse of a conditional statement, the converse of a conditional statement is when you just flip-flop things. So, let me show you a specific example. So you see this example now on your screen. It says, if an angle is 90 degrees, then it is a right angle. That is exactly a conditional statement. This, remember, is your hypothesis. This right here is your conclusion. Wonderful. So this is the P implying the Q. Now, a converse statement, if you start with something like P implies Q, the converse of this statement is just when you flip-flop the hypothesis and the conclusion. So it looks just like that. So I'm not going to write this down. You need to, though, but here's how you would take the converse of this particular statement. It would say, if an angle is a right angle, then the angle is 90 degrees. So that's the converse. It's when you take and flip-flop the P and the Q. Okay, so we got negation. When you negate something, make it not this or negate that, or you converse, you flip-flop. So next thing then is this. You can take a conditional statement and do what we call the inverse. You can inverse a conditional statement. So we got converse, which is a flip-flop. Inverse is a little bit different. So let's do that one. So inverse is this. If the original, again, statement or implication is P implies Q, the inverse is you keep the order the same, but you just negate the first thing, so make it not P, implying not Q. So you just negate this this conclusion, and you negate the actual hypothesis, just keep them in the same order. So again, I'm not going to write this, but you need to. Here's what the wording of the inverse of this green conditional statement would say. It would say, if an angle is not 90 degrees, then it is not a right angle. That's exactly what the wording would be for the inverse. So you just take those things and keep the order the same, but you just negate the first one and negate the second one. Okay? Awesome. Let's go to. So here's the three, and the last one is a very fun one to say. It sounds like an actual video game, but it's called this. It's called the contrapositive. So you got negation, converse, which is flip-flop, inverse, which is keep the order the same, but just negate the two. Beautiful. And then contrapositive is actually this. Follow my words. The contrapositive is actually the inverse of the converse. I'll say it again. The contrapositive actually is the inverse of the converse. So let's go to this example and see if you got it. The inverse of the converse. So the contrapositive, if we have P implies Q, it is the inverse of the converse. So I must first take the converse. That means I take Q and P and flip-flop them. So I take the converse first, and then I take the inverse of that. So it's this. It's not Q implies not P. So I'm not going to write this. You need to write it though. Here would be the exact wording of this conditional statement if I took the contrapositive of it. It would say, if an angle is not a right angle, then the angle is not 90 degrees. If an angle is not right, then it is not 90 degrees. That is the contrapositive. So we got converse, inverse, contrapositive, and negation. And then we're going to talk about whether these things are true or false, because that leads into a huge discussion whether these things are right or they are not right. Because you can converse anything, you can inverse anything, you can contrapositive anything, but that doesn't mean they're still true. So let's talk about that in a little bit. Okay, so what I'll do is I'll show you a quick example of how you can see whether these things are true or not true. If you look at this example right here, this conditional statement, if Harry, whoever that is, lives in Mechanicsburg, then good old Harry lives in PA. Let's assume that that is absolutely true. Now here's the thing. I know there's other Mechanicsburgs out there in the world, believe it or not, other than us in this awesome environment here in Mechanicsburg, in this town, in this beautiful little community, which it is. But let's assume for this example that Mechanicsburg, there's only one in the world and it's in PA. So this is certainly true. Because if this is Harry, let me use a different example. If this is Harry right here, woo, good old Harry, there he is, he's standing right there. If Harry is in Mechanicsburg, then he certainly is within Pennsylvania. That is absolutely true statement. So let's go back a second now, let's look at this one. If I take the converse of that statement, the converse is I just flip-flop the P and the Q. So now it says, if Harry lives in Pennsylvania, then Harry lives in Mechanicsburg. Well, that means I could put Harry over here. I could put him out there above Pittsburgh somewhere, below Erie. I could put him over here in Philly somewhere. Beautiful. I could put him up here in like almost New York City. Well, that's not quite New York City, but whatever. So there's plenty of places that Harry could be living in PA, but not in Mechanicsburg. So that one is false. So you see, sometimes converses are not actually true. Sometimes they're false. Well, what if I do this? What if I take and erase all this stuff? Yeah, so the next one then is this one, which happens to be inverse. So if I take and keep the order the same from the original one, but I negate it. So if Harry does not live in Mechanicsburg, then Harry does not live in Pennsylvania. Was that true or false? So if Harry does not live in Mechanicsburg, that means he cannot be in this box right here. So does that mean that Harry does not live in PA? Well, sure, he could be over here in, New Jersey somewhere. Why would he be in Jersey? I have no idea. Just kidding, people from Jersey. Well, over here in Ohio, he could be over there. But he also could be in Pennsylvania. He could be right there. Well, I don't know what's happened to his head there. Sorry, maybe it must be windy. Regardless, Harry does not live in Mechanicsburg. Then Harry does not live in PA. Wrong. That's absolutely wrong. This proves it correct. This proves it correct. This proves it wrong. And as soon as you find one example that proves it wrong, ladies and gentlemen, that one also is false. So that one doesn't work either. So sometimes inverses are not always true. Now they could be, but sometimes they are not. So if I started with this one being true, remember this one was false, and this one was false. Now we're on to the last one, okay? Which is this one. This is called the contrapositive. So I take the inverse of the converse. So this becomes over here, and you negate it, and this goes over there, and you negate it. Well, let's read this. If Harry does not live in PA, that means he cannot be in this box anywhere. So he can be over here, almost up in New York City, down here in Maryland. He could be over here in Virginia, West Virginia. Again, I don't know why, just kidding, people. Up here in New York, he can be anywhere. He could be way over in California. He could be in Australia, bouncing with the kangaroos. That's true. He doesn't live in PA. Then he does not live in Mechanicsburg. That is absolutely a 100% true statement. Again, assuming what we assumed up here, that there's only a Mechanicsburg in Pennsylvania. So why did I just show you this? Because anytime that you actually see, guys, that an original statement is true, it will always, always, always mean the contrapositive is true. Always. So if the original statement is true, the contrapositive is also true. So that means if you have something like P implies Q, if that's true, and you're assuming that's true, whatever it is, then every single time you know that the contrapositive is also a true statement. Love it. Love it. Love it. All right, we're going to cut this. Okay, last thing is this, which is the following. Okay, there's something, and I put this on the back of your foldable if you see it. It's called chain of reasoning. Now, here's the thing. Let's assume that, and this should be on the back of your foldable, that we have an implication that is true where P implies Q. And then we have another one where Q implies R, whatever that happens to be. And then I have something where it says R implies Z. So if P then Q, if Q then R, if R then Z. The question is, if all three of these things are true, what ultimately could we conclude? I'm going to give you a little hint from Algebra 1. It's called the transitive property. Same concept applies when you're doing this chain of reasoning. If P implies Q, and Q implies R, and R implies Z, you could link all these things together where P goes to Q, goes to R, goes to Z, and you could conclude that right there is true. P implies Z. That's called the chain of reasoning, when you can link those things together. So let me give you a real example from a couple commercials. Now I'm not condoning this company at all. It's DirecTV, but they had some really cool commercials that are exactly this chain of reasoning. So let me play this for you. You're going to laugh, yes, but it's a great example of the chain of reasoning rule, and I want you to think about what they say, listen from the very beginning to the very end, and there's something that you can actually conclude given where they start to where they end. So let's listen.